Agricultural reuse options. We'll see the next topic. So here, treated wastewater for agricultural reuse. What is its importance and all everything we will see. So here the reclaimed water, it is very important and enhanced to secure and enhance for agricultural production is very important, and there are many benefits of water reuse, and several concerns are there which the scientific community is raising, and the challenges the human health and the environment are facing, that is including chemical risk and other factors. Then the effluents, that is from the urban wastewater which is coming plants, usually they are containing a variety of organic chemicals and all, and the chemicals which are there in the water after the treatment process, and this will cause hazards for human health and contaminate the surrounding soil and water resources, and this will compromise drinking water sources. Crops are irrigated sites, they are exposed to chemicals, and the potential transport to accumulation in the edible parts of fruits and vegetables, it is accumulating in that control has to be done. That is it is those chemicals, they are going into the food chain, and this is a concern for the wastewater borne antibodies and into the environment, and this is a concern for the scientists, environmental scientists, food scientists, etc. So, due to these reasons, agricultural irrigation, more stringent quality requirements they have to place in order to minimize this chemical risks which are contaminating the crops and entering the food chain, and even contaminating the water, and reducing the chemicals at the source. Technical for water treatment processes, so these chemicals has to be removed with persistent bioaccumulative and toxic or persistent mobile and toxic properties. Good agricultural practices has to be done, and supplementary preventive measures has to be taken. That is, the knowledge has to be transferred to the stakeholders and all. Always necessary to ensure safe irrigation in the future. So the knowledge has to be given to the farmers, the agriculture sector, in the in city, in town, in rural areas, where the rural areas and even the more rural areas which are downtrodden, they have to be given more knowledge about this by holding small seminars, workshops, or a voluntary organization visiting them and promoting this, so that this is harmful. If new technology comes, they can give them the suggestions and all. And this has to be implemented internationally. Questions remain whether the knowledge, current knowledge regarding chemical risks, it is sufficient considered in the regulatory context. That is, in the regulatory guidelines, all these things has to be there. So that's why they monitor this regulatory or guidelines periodically. Then this has been established water reuse for over many years, and water scarce countries regions, that is around the world, and this date back to park irrigation in California, USA since 1912, potable water use in Windhoek, Namibia since 1968, and agricultural irrigation in Israel since 1950s. So this potable water reuse have been evolved in many ways in US. Israel covers more than 50% of its agriculture water demand with reclaimed water. So this Israel has, before also I think I had mentioned to you about Israel. Israel is a country in the Middle East in deserted area, which is a very dry country. And seeing that the shortage of water and agriculture, they developed many wastewater treatment plants at their coast, and they could recycle that reclaimed water. for agriculture purpose. So it has become the top country in the world now. It is the whole country. It has so much land and agriculture that it is greenery. It is sufficient for its country, and neighboring countries also who require they can export that vegetables, fruits, and all. And in that way, their economy is has increased very well, very good now also economy, and still further going good. So in Singapore, new water meets around 40% of the water demand is there. European Union, it is reusing projects are more numerous in the southern European countries, that is like Cyprus, France, Greece, Malta, Portugal, and Spain. And several reuse projects that also been implemented in the central and northern countries like Belgium, Sweden, and UK also. So innovative projects they are doing around the world, and appropriate technologies they are placing to treat the wastewater and needed quality what they needed, including highly sensitive potable and industrial applications also. So highly advanced water treatment, it is a great cost, high energy requirements are there, and the treatment levels are usually established according to fit to purpose approach, settling water quality goals to end users. It is needed, and this is reflected in a variety of legislation guidelines which are there for water reuse, which has been adopted by World Health Organization, that is WHO. Okay, and the guidelines for wastewater in aquaculture and all it has been used, and for potable reuse and obeying the guidelines of the ISO guidelines 16005 is treated for use for irrigation purposes or agriculture purposes. So they have to follow these guidelines, WHO guidelines and other guidelines also, and ISO guidelines 16075 for treated wastewater use for irrigation purposes, agriculture. Okay. Then opportunities and what are the benefits of water reuse. So this will become more important in the water scarce countries and regions that are shortage of water, the recycling of wastewater. It is one of the opportunities in order to substitute limited fresh water which is there with reclaimed water for purposes that do not require drinking water quality. So urban wastewater, this is which is usually continuously throughout the year, and it can provide a reliable water source. While freshwater availability, this can be characterized by high seasonal variations or extreme events will be there. High seasonal variation, sometimes heavy rains will be there, sometimes moderate or average rains, or sometimes no rain. Drought might be there. On that, it will depend. So the patterns they are changing more likely with the climate change going on at the global level, and water reuse opportunities have increased interest not only in arid countries but also developed countries. Uh, they are trying to develop new technologies, new processes for reuse of the water and all. So potential reuse water applications at the agriculture sector, it is and the landscape irrigation, industrial reuse, because industrial reuse they require a lot of water for developing, producing variety of commodity chemicals or variety of products which are used at the domestic level and industrial level also. Then urban applications for firefighting, street cleaning, as well as recreational and ecological uses. These are very, very important in recreational activities, that is parks, swimming pools, and gardens, and ecological uses in uh, wildlife also needed, and in natural also it is needed, and the community also. households they also require. They'll be having the garden, recreational facilities, all those. They have to reuse these water. So the market share around the world is 30%. Agriculture it is going, and the most of the application of reclaimed water it is on average. Agriculture accounts for 70% of global freshwater withdrawals. So these are the opportunities and benefits of water reuse. Then water shortage in agriculture, far-reaching effects on food security. It will be nutrition, livelihoods, and other socio-economic aspects. It is becoming more relevant in these areas. But reliable water supply, it can help and alleviate these pressures or these problems, uncertainties with the population growth. That is main. With that, the increasing food demand, pressure on water resources, increased water productivity has to be there in agriculture, which is very, very important. For example, in Australia, the water use is facilitated an increase in agricultural production, and despite the limited availability of freshwater resources. In Tunisia, in Africa, where wastewater use is well established practice here, reclaimed water that is for agricultural purposes, and this consists of about 20% of wastewater effluents that will be promoted by state in order to save fresh water for the drinking water supply and to protect receiving waters. So irrigation with reclaimed water may also have benefits, that is in terms of providing nutrients to crops. So thus potentially reducing the need for synthetic fertilizers in agriculture. So there is a balance, ensuring balance should be adequate between wastewater treatment and adopting nutrient loads in reclaimed water that is to specific crop requirements and their seasonal variations that can be very challenging. And otherwise, excessive nutrients may cause plant damage or crops damage, you can say, that will leach into the ground water or surface waters as well. So water reuse can complement or supplement that is measures for water saving efficiency. It should not replace them. Then here irrigation with the reclaimed wastewater containing pathogens and contaminants. You can see first one is the direct contact. It can be inhalated or unintended ingestion. It can be the responsible persons could be workers, farmers, residents, public also, and pathogens on the edible part of the plant. If they are there, pathogens this that can be going to the consumer. People who will be taking those vegetables or fruits. Then uptake of contaminants by plant. The plant absorbs those contaminants that is consumed by the consumer. People accumulation, leaching, breakthrough of the contaminants. Leaching will be there of those contaminants going into the ground, and it will contaminate the groundwater, surface water, and even the soil. Then there will be breakthrough of the pathogens that will be leading into the groundwater and drinking water. Contamination of the pasture, animal feed, forage, all these, those are animals in the consume. So this is the simplified overview of the exposure of pathways during water use for agricultural and irrigation. Okay, for that. So if you remember this table easily, you will understand the irrigation with reclaimed wastewater that is containing pathogens and contaminants, which people are affected and how it is affected the consumer, the people, even the leaching of those contaminants in the ground, affecting the groundwater, surface water, and the soil also. That way, and affecting the environment and breakthrough of the pathogens going into the groundwater and the drinking water. So, contamination of pasture, animal feed, forage is consumed. Risk of water use, chemical risk are potentially there. It depends on the source and the composition of water, its treatment, is how it is stored and distribution, and the type of irrigation technique they are using, agricultural practice, and as well as climate, soil, and groundwater condition. These are very important, which are contributing to the specific chemical risk that is coming out of the water reuse. So everyday products we are using, such as pharmaceutical, personal care products, cleaning agents, plastics, other lifestyle products, um, depending on different activities where how you are using these, and thousands of these chemicals there will be released: antibiotics, beverages, food additives, preservatives, corrosion inhibitors are there, textile chemicals, biocides, and just a few examples which are contaminating coming into our wastewater from these industries and all. And some of these chemicals, they have persistent, bioaccumulative, they are toxic properties and defined as substances of very high concern. That is according to the European Chemicals Regulation Act, each. Yeah, these regulations are not only the European, the WHO and the water quality bodies, they follow the guidelines, they put it on particular country. They have the water bodies, like we have in Namibia water quality regulations, Namibia water quality board we have, that comes under Ministry of Environment and all, Ministry of Mines also. So other hazards for the water recycle, they are due to persistent, mobile, or toxic preemptive properties. Urban wastewater treatment, it will eliminate many chemicals. To some extent, it is limited, and this will be depending on the different treatment conditions, on input loads, mobility, that is resistant to degradation. So, in practices, exposure to humans and animals, it is reduced by limiting accessibility to fields, irrigated, that is with reclaimed water it is going on, or by directly preventing the contact between the edible part of the plant and the reclaimed water. So in irrigation technologies, drip irrigation is there, subsurface irrigation not only reduce potential exposure to pathogens and contaminants, but efficient promoting water reuse, efficiency, and reducing the potential of accumulation and leaching. These are very, very important um, things in the irrigation technology. Access control measures has to be there, including safety distances between the irrigation fields and public accessible areas. Safety distances have to be followed. Reduced potential contact has to be reduced, otherwise it will affect the health, because any number of toxic chemicals are there, toxic microbes might, there, it might affect the human health. Additional measures, this will include adequate signage of fields irrigated with reclaimed water, as well as pipes transporting the reclaimed water, and due to issues concerning the quality of reclaimed water. Crops for raw consumption or particularly sensitive areas, that is, example, cars. This is excluded from water use for irrigation. Irrigation practices, exposure to humans and animals, this can be reduced by limiting accessibility. Okay, then fields irrigated with reclaimed water, and preventing direct contact, that is between the edible part of the plant and reclaimed water. This and drip. I think we have seen this. Right? Yeah, the chemical quality of the reclaimed water, this is very important from the safety point of view for the agriculture, using water containing organic microcontaminants, all this, that is even risk to the soil, groundwater, and human health. And major objective is to prevent chemicals that is accumulating in the food chain, which is very important. And this will enter the groundwater and used for drinking purposes also. And this has been addressed very carefully in the guidelines, regulations that has been adopted on water use, agricultural irrigation by the EU, proposed regulation, not only the EU, World Health Organization and EU PSA, also guidelines. So periodically they will be assessing all these things and deriving the necessary requirements and measures which are required here. So guidelines are there, should include sufficient details to promote widely harmonized, that is, risk management is also there, approaches and systematic monitoring is there, and monitoring suitable indicator substances, quality control is established for reclaimed water. Quality control is there in order to monitor the raw water and the treated water, what contaminants are there still, or are they removed, best methods they are using for the environmental practices such as soil and groundwater at the irrigated sites. Okay.